हेलो अस्सलाम वालेकुम। आवाज़ आ रही है आप लोगों को?
यस सर।
ओके। स्क्रीन में शेयर कर देता हूँ। ओके। होपफुली स्क्रीन आपको नज़र आ रही होगी आपके सामने। ओके, सो दिस इज योर गूगल क्लासरूम। उसका जो सामने आउटलुक है, यू कैन सी इट। ओके, यू ऑलरेडी नो अबाउट स्ट्रीम। You already know about different sections in your Google Classroom. Okay, so if you go to your classwork section in Google Classroom, you will be able to see the different sections that we have. Okay, so the first one is basically the course outline or course content, then the course learning outcome that we want to achieve with this course, and the evaluation criteria. So all are basically given over here. You can download it from here. So the course content, that is kinematics of particle, kinetics of particle, plane kinematics of rigid bodies, and plane kinetics of rigid body. So the book that we have to follow for it, it's basically engineering mechanics dynamics by J.L. Merriam and by R.C. Hibler. So it doesn't matter whichever edition you have, you can follow. And we may also we can also use that book by Beer and Johnston. So these three books are recommended for this course. You can use any other reference book, but at least these three books can be used. Okay, the course learning outcome that we want to achieve from it. So basically, four CLOs we have to achieve with this course. So it's mentioned over here, and the course evaluation criteria that we usually have for our semester system, it's 60% final term, 20% midterm, and 20% sessional. So sessional, again, it can be like class participation, assignment, quizzes, presentations, and attendance. So it depends on the activities that we carry out during our semester. Okay, so the percentage for general, for on-campus classes, it will remain like this. However, for online classes, last time it was changed, but this time no such notification. So uh, until something is notified, we will stick with this one. Okay, then here is the timetable. So we will try to follow this timetable. But it's like online system, so if needed, we can modify it based on consensus, like based on the availability of time. The books that we will use, the two books that mostly we will use in this course, it is basically engineering mechanics dynamic portion by J.L. Merriam. It is the dynamic book written by J.L. Merriam, and then the engineering mechanics dynamics by R.C. Hibler. So it is basically one book from chapter 1 to chapter 11. It's having static portion, and then from 12 onward it is having dynamic portion. So both books are given over here. uh, Solution manual of JL Merriam, I think solution manual of RC Hibler is also available, but at least I have one. So if you couldn't find, I can provide you. Okay, the class lecture that we will use, they are also given over here. Means we had our lecture 1 and 2, so both are given over here. Then today we will go through our lecture number 3. Similarly, the video recording for lecture number 1 and lecture number 2 is given over here. So you can means check all those things from here. For example, if you want to go through your today's lecture, just click on it. If you want to download it, open a new window and you will get that download sign over here. So uh, this is just to let you know people that our Google Classroom is maintained, and if you want any data, you can get it from here. Regarding your assignments, your and your quizzes, so your midterm, your final term, or material related to midterm and final term or course, everything will be uploaded over here. Okay, so let's go back to your Google Meet section. I will stop complete screen sharing. Okay, so I will give you a recap of last lecture, means last week's like two lectures, and then we will go onward. But the topic that we are going to discuss are the main topic that we want to cover in this class. It is basically kinematic of particle. So I already know what is kinematics. I will revise it for you people. So, but the major topic for today's class, it's kinematics of particle. Okay, you already know what is engineering mechanics. We have discussed it in very much detail in our previous semester as well as in our previous classes. Uh, but still, let's revise it. That the study of how rigid bodies react to forces acting on them. That is basically known as engineering mechanics, or we say it's the study of engineering or branch of engineering in which we study the behavior of rigid bodies when forces acting on them. So if the result of all forces acting on the body, if they causes no motion, if the object remain in rest, so it will be considered as static, or it will be analyzed in static portion. But if there is motion as the result of forces, so it will be mean that study will come under the umbrella of dynamics. So the study of motion, and again, the here in dynamics we are having the study of motion, but the study of motion again it can be subdivided into two sections. Whether you are considering the forces which basically causes that motion, or which basically causes the different sort of motion or type of motions or not. So if we consider the forces which basically causes the motion, then that branch or that section will be known as kinetics. But if we don't consider the force which basically causes motion, so that will be known as kinematics. In other words, we can say in kinematics we will just study the geometric aspect or the relationship between displacement, velocity, acceleration, and time. Okay, so this is like the mathematical term for Newton first law of for statics, which is basically based on Newton first law, in which the effect of all forces acting on body, they basically cancel out each other, and the resultant force is zero. Whereas for dynamics, in last class we discussed that it is based on Newton's second law of motion, which is the summation of all forces acting on the body. They are basically causing some acceleration, and we can get that equation from Newton's second law, which is F is equal to ma. Okay. Uh, During class, if you don't ask any questions, so I will assume that you people are getting me. ठीक है, अगर कोई क्वेश्चन हो सकता तो आप अपने साथ लिख भी सकते हैं, and you can ask me in between the lecture. Okay, so what is kinematics? As I have just told you that it is concerned with the geometric aspect of motion. That is SVA, S is displacement, V is basically velocity, A is acceleration, and time. So here in this slide, what we did basically, I have shown this displacement, velocity, and acceleration as scalars. This is just for simplification purpose. Otherwise, displacement, velocity, and acceleration, all of them are basically vector quantities. Okay, so suppose we are having a body at certain time, that is, let's say at time t is equal to 0, it covers some displacement uh, during time t. Then again, if we give some more time to it, or in some differential time dt, it covers some more displacement, which is ds. So we can get something like this. So the distance covered between t and dt, that is basically ds. So the total distance cover, or total displacement cover, it is basically s plus ds. So what is distance, what is displacement, what is the difference between these two? So we will study in our coming lecture. So as we already know that the rate of change of displacement, that is known as velocity, and the rate of change of velocity is basically known as acceleration. So these are the basic concept that we got from our physics or from our physics course. So this is the basic knowledge that we already have. Okay, so velocity is basically rate of change of displacement, or we can say this is basically ds by dt, and acceleration is basically a rate of change of velocity. So this is dv by dt. So instead of if we put this ds by dt, so it will become double differential, and this will become d square of displacement divided by dt square. Okay. So again, continuing with particle kinematics. So in particle kinematics, we can have different sort of motion. We can have rectilinear motion. Rectilinear motion is basically motion in a straight line. We can have motion in a circle, which is known as circular motion. We can have curvilinear motion, that is basically motion along certain curved path. So we will study all of them, but in today's class we will focus on rectilinear motion. So the first one that we have, it is basically rectilinear continuous motion. Okay, kindly give me a second. Okay, so motion. Let's study these different types of motion. That means what sort of motion can we have, as I just explained. So a body or object is said to be in motion when it is observed moving or changing position relative to a fixed reference as time passes. So means why we use this word fixed reference, because if an object is moving and our reference is also moving with it, so relatively there will be no change in position. There will be no change in position between the reference as well as the moving object. So if the object is fixed and means the reference is fixed and the object is moving, then in that case we can have motion or relative change in position of both objects. So that's why in definition we have a body or object is said to be in motion when it is observed moving or changing position, but it is relative to a fixed reference as time passes. So to observe the motion or to observe the change in position, to locate the position, again we use different sort of coordinate system, and based on this we study the motion, or we basically study the different position, and we already know about the coordinate system, what sort of coordinate system we can have. So the coordinate system, it can be like linear coordinate like Cartesian coordinate, and it can be polar, cylindrical, or spherical. So polar, again, it's for 2D, and that cylindrical and spherical, it's for 3D. We already know about it. Okay, so the different sort of motion that we can have, it can be like rectilinear motion. Okay, it can be rectilinear motion, that is motion along a straight line. Then we can have a circular motion, that is motion along a circular path. And then we can have curvilinear motion, that is motion along a certain circular path, or along a certain curve, not a circular path. Okay, now what is distance? Distance basically show that how far an object can travel, and it does not depend on direction. Means distance is like you can say it's just simply a magnitude, it's just a value, a scalar quantity. Then displacement, what is the difference between displacement and distance? Or displacement can be defined as the difference between object's final position and its starting position, and it do depend on the direction. For example, if we have an object and that object is initially over here, it moved from this position till this position. So now in this case, the final position minus initial position, this will give us displacement. Whereas the distance travel, again, it's the same. But if the object come back from that position and it reaches initial position, Now in this case, the difference between final position and initial position, it is zero. So this means the displacement in this case is zero, but there is certain distance covered. So the distance covered, this is basically this whole one, mean this distance plus this distance. Okay, so how we can define the displacement? Displacement is basically the difference between the object's final position and its initial position. Okay, now speed. We already know that what is speed? It is basically rate at which object is moving, or we can say it's the distance covered per unit time. So speed can be mathematically written as the speed is equal to distance by time, or in terms of alphabet, if you want to write, for s is equal to d by t. So like distance, again, speed does not depend on direction. If you want to make it like if you want to include direction with the speed, so that will be then known as velocity. So how we can define velocity? We can say that it's the speed with direction, or in other words, we can say it's the rate of change of displacement, or the change in displacement per unit time. So velocity, in this case, this is basically displacement per unit time. So over here we were having distance. So distance is scalar, whereas displacement is vector. So that's why velocity is also vector quantity, means it needed direction also. So we can be written as, again, delta d by t. It has magnitude as well as direction. We usually use the term magnitude with scalar quantity as well as with vector quantity, but in vector quantity we also required direction with magnitude. So what is magnitude? It is basically a measurement that has some certain value. For example, 26 kg, or we can say a 19 meter. So it is basically a measurement that has some value. Now what is acceleration? Again, if we simply want to define, so it's the rate of change of velocity, or change in velocity per unit time. Over here, what we have, it is a vector which shows the direction and magnitude of changes in velocity. So it is having the same meaning which we just discussed, or which just I told you. Uh, and sometimes sometimes our in our calculation we use instantaneous acceleration. So what is instantaneous acceleration? This is the rate and direction at which the velocity of an object is changing at one particular moment. Means at a given time, at a very short interval of time, the change in velocity, or that instantaneous time, the change in velocity, that is basically known as instantaneous acceleration. So this is basically rate of change of velocity at one particular moment. So sometimes when we want to show it mathematically, so we basically use that when t approaches to 0. So that is basically the condition for instantaneous acceleration. Okay, now position. So we already know position. The position of object can be defined with respect to some reference, and for defining the position, we basically use coordinate system. So a particle moving along a straight line is said to be in rectilinear motion. We already know this thing. At any given instant or any given time t, the particle will occupy a certain position on the straight line, and then that position can be specified with the help of variable of coordinate system. Now to define the position p of particle, we choose a fixed origin, like the means the reference point. It is a fixed origin on a straight line and a positive direction along the line. So for example, we have this particle, it is moving, this particle is moving. Now to specify its direction, to specify its position, what we basically do, we choose origin, and then we specify the positive and negative. We set some reference for us, and based on this we measure the position, or we measure the distance that it travel. Okay, so the distance can be in positive direction, it can be in the negative direction. Then to define the position p of particle, we choose a fixed origin o on the straight line and a positive direction along the line. We measure the distance s. This is basically the distance s from o to p, from o to p. Over here, this is basically uh, p, and recorded as plus or minus sign according to whether P is reached from O by moving along the line in positive or negative. So if it is moving in this will be positive, and according to our convention, if it is moving in the opposite direction, it can be negative. So we measure the distance S from O to P and record it as plus or minus sign according to whether P is reached from O by moving along the line in positive or negative direction. So again, same thing has been explained over here. Means to uh, show the magnitude of distance, to show uh, the distance covered by an object. We need to use some unit system. So the unit use, it can be like meter, it can be feet, or it can be some other system. Okay. Now displacement. So as I have already told you that for displacement you also need to mention the direction. So for example, the displacement of particle is defined as the change in its position. For example, if a particle moves from point P to P dash, the displacement in this case, okay, initially the particle is at P, it moves from P to P dash. So the change in position, let's say it is represented by delta S. So we know that the change in position is basically known as displacement. So how we can find out this displacement? So this is basically the current position minus the previous position, means the final position minus the initial position. So final position from origin, it is S bar, and initial position, it was basically, if we compare it with the origin or we take it from the origin, it was S. So delta S is basically S dash minus S. So in this case, delta S is positive. Why positive? Because in this case, we have taken the direction on the right side as positive, and if you are moving from O towards left, so it will be negative. As okay, if our initial position was this one, and if you move toward left, so in that case, delta S can be negative. So in this case, delta S is positive since the particle's final position is to the right of its initial position. That is, S bar is greater than S. Likewise, if the final position were to the left of initial position, then in that case, delta S would be negative. Okay. आप सबको आवाज आ रही है ना?
Yes, sir.
Yes,
ओके.
sir.
इन बिटवीन अगर
Yes,
आवाज
sir.
कट जाती है, कोई मसला होता है, तो आप मुझे इन्फॉर्म कर दिया करें. ठीक है?
Okay, sir.
Okay. So now velocity, as we already know that this is basically the change in displacement per unit time, or we can say it's the rate of change of displacement. So since displacement is a vector quantity, so velocity is also vector. And if we say, like for example, the distance covered per unit time, so distance is basically scalar quantity, and the resulting thing, which is basically the speed, it is also scalar quantity. Okay, so let's study this velocity. For example, we are having an object at initial point, at initial point, that is at point 1. Let's say it's 1. So the position or the displacement that we were having at point 1, it was S1 when the time t was t1. When time was t1, the displacement was S1. So after change in time, when time was t2, the displacement, it became S2. So the displacement or the change in position, initially the position was S1, now the position or the displacement is basically S2. So the change in displacement during time change, and the time change in this case, it is basically t2 minus t1. How you can find out the change in displacement? Initially at position 1, the displacement was S1. Now at position 2, the displacement is S2. So change in displacement, it can be S2 minus S1. Okay, whereas the time that in which the change took place, that is basically given by t2 minus t1. So usually we in dynamics or in our calculation, we use average acceleration or average velocity. So v average can be defined as delta S by delta t. What is delta S? Delta S is basically displacement, and how we can find it out? By S2 minus S1. And what is delta t? This is the change in time in which that displacement basically took place. So that is t2 minus t1. So these are basically simple thing which we already know. Okay, as I have discussed that instantaneous acceleration, so we can also have instantaneous velocity. So instantaneous velocity in that case, that the time t will approaches to zero. So when this time t approaches to zero, that will become instantaneous velocity. And in this case, we can simply write v is equal to ds by dt. Means in such small time duration, in such small instant, the change in displacement, it will also be very, very much small. That's why we represent that change in differential term, ds by dt. Okay, so velocity, it can be positive, it can be negative. So it depends. If the change in displacement, if the displacement is positive, so the velocity will also be positive. If the displacement is negative, so in that case the velocity will also be negative. So it basically depends on the displacement. So I have shown this one over here. If the particle is moving to right, the velocity is positive here. If it is moving to left, the velocity is negative. So both are basically shown over here, mean the right side direction, this means positive. Okay, now acceleration, as we already know that acceleration, it is the change in velocity per unit time or the rate of change of velocity. So provided the velocity of particle is known at 2 points, if we know, for example, we are having 2 points, one is basically point 1, one is basically this point 1 and the other one is point 2. If we know velocity at this point and we know velocity at this point, so you can see with this arrow, velocity over here is having some magnitude, and the magnitude of velocity over here, it is different. So now at point 1 and point 2, there is change in velocity, and the velocity in this case, if you look at the arrows, this basically reduces. So this change in velocity during this time change, this is basically known as acceleration. So average acceleration can be given as this change in velocity delta v divided by delta t, and we can write it as v2 minus v1 divided by t2 minus t1. For instantaneous acceleration means the change in velocity at a given moment, so means when that delta t approaches to zero, in that case the change in velocity again, it will be very much small. So we represent it with differential term, that is dv by dt, and we already know that v is equal to ds by dt. So d square s by dt square, it will become like this. Okay, so both the average and instantaneous acceleration can be either positive or negative. Means both are basically vector quantities, and it can be depending on the direction, depending on the velocity. If the velocity is increasing, so it can be positive. If the velocity is decreasing, it can be negative. So in particular, when the particle is slowing down or its speed is decreasing, the particle is said to be decelerating. In this case, the v bar is less than v, means the final velocity will be less than the initial velocity, and that delta v, it will be given as v bar minus v, and the result that we will get, it will be negative. Similarly, uh, if a is negative, this means it will act towards left, that is in the opposite sense to the v. Also, when the velocity is constant, if there is no change in the velocity, this means acceleration will be zero. There will be no acceleration, there will be no deceleration. Means if velocity is constant, if the final velocity and initial velocity is same, so this means change in velocity is zero, and the in equation, if you put that delta v is equal to zero, so the acceleration that we got, it will also be zero. And the unit that we use basically for velocity, it is meter per second, or it can be foot per second. Similarly, the units that we use for acceleration, it is basically meter per second square, and for in case of foot pound system, it can be foot per second square. So over here you can see, initially we were having smaller velocity, then the velocity increases. So final velocity is greater than initial, means v bar minus v, uh, that will be a positive value. So this means we are having positive acceleration, or the change in velocity is positive, or the acceleration value is positive. This means we can term it as acceleration. Okay. If velocity is initial velocity is greater and then the velocity reduces, so the velocity is decreasing. So this means in this case, we will not use this term acceleration, rather than we can use negative acceleration, or another word which is known as deceleration. Okay. So from the previous equation, what we get few equations, and based on those equations, we can get three basic kinematic equations, and these three basic kinematic equation will be used throughout your dynamic course. Uh, and how we can use these three kinematic equation, we will see it in a moment. Okay. So these three basic equation, let's go through these equation. The first one is basically velocity. So velocity, we already know, this is basically displacement divided by time, ds by dt, or we can say it's the change in displacement uh, in a given time change. Okay, and we already know acceleration, so this is basically the change in velocity in a given time change, dv by dt. So these are basically the basic equation. Okay, so now from this one, we can get the value of dt. So if I get the value of dt from this equation, what we will get? We will get dt is equal to ds by dv. And from this equation, if I get the value of dt, so what I will get? I will get dv by a. So this is dt. Now this equation will become dt is equal to ds by v. This equation will become dt is equal to dv by a. Since both are dt, so we can compare both. We can equate both equations. Okay, so when you equate both these equations, what we will get? ds by v is equal to dv by a. Since over here we are having dv, so let move this dv, this v over here. So this one will become v dv, and let's move this a over here, ads. So this is another equation, ads is equal to v dv. So these are basically the three basic kinematic equation which will be used throughout your course. Okay, let's go through an example. The velocity of particle moving along straight line. Straight line means we are having rectilinear motion. The velocity is given by this equation. V is equal to t square plus 2t, and the unit over here is basically meter per second, where t is in seconds. If its position s is equal to 0 when t is equal to 0, so initial position when time t was 0, so the position was also 0. Determine its acceleration and position when t is equal to 4 seconds. So we are having initial condition, that is s is equal to 0 and t is equal to 0. What we need to do, we need to find out the acceleration and position. We need to find out a and s when t is equal to 4 seconds. So the equation that we have, it is basically v is equal to t square plus 2t. Uh, we need to use this equation. So if you look at over here, we need to find out uh, acceleration, and we need to find out displacement. So we can use these two equations. In this equation, instead of v, we will put that value, and then we can find out this acceleration. And in this one, to find out this displacement, we can put v over here. So let's see. Uh, when t is equal to 0, s is equal to 0. This is the given condition. When t is equal to 4 seconds, we need to find out the position and acceleration. So as I have just told you, acceleration is equal to dv by dt. So instead of v, what we will do, we will put this equation. So for v, we put t square plus 2t divided by dt, and you know that how we can solve it. So uh, it's very basic differential equation. So we can solve this one separately and this one separately. So when you find the differential of t square, it will become 2t, and when you try to find out the differential of t, it will become 1. So 2 multiplied by 1, it will remain as it is. So 2t plus 1, this is basically the acceleration when it is function of time, acceleration as a function of time. So at time t is equal to 4 second, at time t is equal to 4 second, what we can do, we can basically put this t is equal to 4 second and we will come up with the answer. So at this instant, when t is equal to 4 second, the acceleration that we got, it was basically 10 meter per second square. Now for displacement, as I have told you, we can put v value over here and we can find out displacement from this one. So now in this case, what we need to do, we need to find out the s. So we have ds, we need to find out s. So this means we need to remove this differential term. So to remove this differential term, we used to use anti-differential, which is basically integral. Okay. So since v is equal to ds by dt, so let ds be on one side and v dt be on other side. So for v, we will put this equation t square plus 2t, t square plus 2t dt and ds on the other side. So we can integrate this one. Okay, give me second. I got a call. Okay, so let's move back to our class. Okay, so when you put this value over here, instead of v, we have put this t square plus 2t dt is equal to ds. So we need to integrate it from time t is equal to 0 till time, whatever the time limit. In this case, the time limit is basically 4 seconds. So from it would be from 0 to 4. Okay. And the displacement initially it was 0, and now we are having certain displacement s. We basically want to find out that displacement. So the equation will become, this one will become s minus s naught. So our s limit s into 0. So when we put s is equal to 0, we will get only one term, that is s. and this one will become, if you want to find out integral of this one, so this is t square, we will add 1 in power and divide the whole by it. So 2 plus 1 divided by 2 plus 1, this will become t cube by 3, and for this one it will be 2t square divided by 2. Okay, so 2 will be cancelled out, and what we will get 1 by 3 t cube plus t square, and this will be displacement as a function of time. So when t is equal to 4 seconds, we will put the value of time in this equation. When you put the value of time in this equation, you will get s is equal to 37.3 meter. And this is basically required. What we need to find it out, we were required to find out the acceleration and the position when time t was 4 seconds. So we basically find out this acceleration as well as the position when time t was equal to 4 seconds. ओके, आपको ये स्क्रीन फुल नजर नहीं आ रही? स्क्रीन नजर आ रही है आप लोगों को?
Yes, sir.
जी सर.
Okay, so now let's go through another example. The acceleration of particle moving along straight line A is given by square root s, where s is in meter if its position s is equal to 0 and velocity v is equal to 0 when t is equal to 0. So this means at time t is equal to 0, the acceleration as well as velocity was 0. So determine its velocity when s is equal to 16 meter. So now in this case, the final position is given, and you need to find out basically the velocity, and you also need to find out the time at that instant. So now in this case, we are having this equation: a is equal to delta s. So what equation we can use? We are given with acceleration, and we are required basically to find out the velocity. So let's see. We are basically, okay, we have equation for acceleration and we need to find out velocity. So we directly use this equation. Instead of a, we can put square root s. Okay, square root s ds and v dv. Now to find out this v, what we basically do, or what we can do, we can take integral of this one, integral of this one. So integral of this one from 0 to s, and this one again velocity from 0 to v. Okay, so delta s, or another word s raised to power 1 by 2. So when you take its integral, what we will get 1 plus 2 plus 1. Okay, so this one will become 3 by 2 in power and divided by 3 by 2. So denominator 3 by 2 or multiplication 2 by 3, both are same. Okay, so you will get this term like this, and on the right side what you will get, whatever is the power, we have 1, add 1 with the power and divide by same. जी
सर ये कर्सर नजर नहीं आ रही है, इस वजह से हमें पता नहीं चलता.
okay, okay, okay. This is the equation basically. This is the equation, and we are having this equation is given. Till this point it is clear? यहाँ तक clear है?
Yes sir.
Okay.
Yes, sir.
What we need to find out? We need to find out the velocity, and we need to find out the time. Initially, when time t was 0, the position or the displacement as well as the velocity was 0. Now at displacement, when the displacement was 16 meter, or the final position was 16 meter, at that instant we need to find out velocity and time. So since the acceleration equation is given, so we will use equation in which acceleration is involved and in which velocity is also involved, because we want to find out the velocity. So instead of this acceleration, what we can do, we can put basically this value, which is delta s, this delta s, and remaining equation will remain as it is. Okay, now delta means square root s, means that is basically s raised to power 1 by 2. Both is having same meaning. So take integral on this side, take integral on this side, and integral will be definitely from 0 to s for displacement term, and for time again it will be from time t is equal to 0 to any time which is basically t, and for velocity initially from 0 to any velocity v. So in this case we have displacement and we have velocity, so we integrate basically that equation. So for integral, the rule is basically whatever you have in power, add 1 with it and divide the same on it. So when you add this one with this thing, so what you will get 3 by 2 in the power, which is this one, and you divide the same on this one, 3 by 2. But you take that, when you take the denominator into numerator, it will become 2 by 3. Is it clear?
Yes, sir.
Okay.
Yes,
And on the
sir.
right side, what we have one power. So when you add one with it, that will become v square and divided by 2. So this one will become like this. Okay. Now when s is equal to 16, so we are having s value, you can easily find out this v. So when s is equal to 16, put that value over here, and you can find out the value of v, that is 9.24 meter per second. So the velocity at that instant when s is equal to 16 meter, it is basically given over here, or we have determined that uh, velocity. Now one more term, which is basically what time is that. So we need to find out that thing also. So we have these equation, you can look at this one, we have this equation, we have this equation, we have this equation. So we can use any of these equation. So now we need to look at it, at what equation can we use it. So we need to find out, we now have velocity, we now have acceleration. So you can take either this equation or this equation or this equation. You have to think over these equation. So let's do it. So as velocity is basically equal to ds by dt, and ds by dt is basically equal to acceleration. So no, so sorry, the velocity basically equal to ds by dt. And from this one, here we got this velocity term, dv by dt is actually equal to acceleration. My mistake, sorry. Okay, so instead of velocity, we will put this equation 2 by 3 square root 3 into s 3 by 4. So instead of velocity, we will put this equation, and ds by dt, it will remain as it is. Okay, so from here, what we can do basically, you can shift this term over here. So when you shift this term over here, this s, it will, because ds is here, so that one will become s minus 3 by 4. Okay, or you can divide it here and then move upward, so again it will be minus 3 by 4. And when you shift this term over here on this side, so what you will get, okay, instead of this 3, you can put square root 3 multiplied by square root 3. So one square root will be cancelled out with this one, and this one will become 2 divided by square root 3. When you take it to this side, it will become under root 3 by 2. Means instead of this one, what we can do, we can write it like this. Okay, so we can cancel out this one, we can cancel out this one, and what we will get, 2 by under root 3 on this side. So when you shift it here, under root 3 here, 2 here, and t will be here on this side. Okay, and when you shift this s 3 by 4 over here, so when you want to take it upward, it will be s minus 3 by 4. Is it clear? First here, and then from here to here, so it will become s minus 3 by 4. So this is the equation. समझ आई यहाँ तक?
Yes, sir.
Okay,
Yes, sir.
so now what we need to do, basically we need to find out the time. So we already know about the initial time, which was 0, but we need to find out the final time. So what we will do, we will integrate this one, we will integrate this one, because we know the initial position, we also know the final position. The initial position was basically 0, and the final position was basically 16 meter. Okay, so in initial position, so when we integrate this one will become t, and the limits will be t 0. So when we put 0, only one term will be left with us, that is t. Okay, in this case, what you need to do, you need to integrate this one. So minus 3 by 4 plus 1, when you do it, what you will get, basically you will get as 1 by 4, as 1 by 4, and the same will be divided. So when you solve it, you will get finally this equation. Now in this case, we have to find out t, whereas s is given in the question. So s is equal to 16 meter, the time interval at that instant will be 6.93 seconds. So this was basically required in the question. So two things were required. One was the velocity, and the other one was the time at s is equal to 16. So we basically found out the velocity and the time at that instant. ओके, सो होपफुली आपको समझ आ रही होगी नाउ. Okay, whatever I'm doing so far is it's basically given from RC Hibler book, and same thing is also given in your JL Merriam book. If you don't have those books in hard form, you can download it from the Google Classroom. I have given both books over there. ठीक है. Regarding your problems, your exam problems or your quizzes या कोई भी और ऐसा assessment material के लिए uh, you can take help from this book, from Hibler as well as from JL Merriam. So what you need to do, you need to go through a number of problems. आपने काफी ज्यादा प्रॉब्लम्स करने होंगे. सैंपल प्रॉब्लम करें, प्रॉब्लम में से जो मैं आपसे कहूँ वो करें. इसके अलावा अगर रेलेवेंट प्रॉब्लम कोई आपको नजर आते हैं वो भी आप कर लें, क्योंकि जो एग्जाम में आपके पास है वो इस बुक से भी हो सकता है, हिबलर से भी हो सकता है, वो नॉर्मल जो बुक में प्रॉब्लम है उसमें मॉडिफिकेशन भी हो सकती है, अपनी तरफ से भी कोई प्रॉब्लम हो सकता है. ठीक है. बट इफ यू गो थ्रू some of the problems in this book, if you understand the theory, it will be easy for you people to solve those problem in your exam. सो यहाँ पे अगर मैं आपको कोई प्रॉब्लम बताता हूँ कि आप ये प्रॉब्लम कर लें, तो दिस डजंट मीन कि वही असाइनमेंट या क्विज या पेपर में वही प्रॉब्लम आएगा, बट दैट विल हेल्प यू पीपल एटलीस्ट टू गेट द कंसेप्ट, जो कि आपके इन फ्यूचर या फिर आगे एग्जाम में आपके काम आ सकता है. ठीक है. सो इस एट द एंड जो क्वेश्चन मैं आपको सजेस्ट करूंगा वो बेसिकली शायद जेल मेरियम से हो, बट आप उससे जो आरसी हिबलर के एग्जाम्पल्स और प्रॉब्लम्स है वो भी आप कर सकते हैं. सो फार वट एवर आई एम डूइंग ओवर हियर, ये एग्जाम्पल वगैरह जो है ये आपके आरसी हिबलर बुक से हैं. ओके. सो अगेन इन चैप्टर 12 दिस इज एन एग्जाम्पल 3. I don't remember the exact problem number in the book, but you can check. This is an example from RC Hibler. The car in this figure moves in a straight line. Straight line, so this means rectilinear motion, such that for a short time its velocity is defined by this one. Short time means instantaneous. Okay. So the velocity is given by this equation 3t square plus 2t, and the unit is basically foot per second square, where t is in seconds. So what you need to do, determine its position and acceleration when t is equal to 3 seconds. So at any given instant when basically the t was 0, that one here, s was also equal to 0. And when t is equal to 3 seconds, what you need to do, basically you need to find out position and acceleration. Okay. So the first thing that you can do, you can define some origin. Like let's say this is the origin for my problem, and let's say the displacement in this direction is positive. So the position coordinate extend from fixed origin to the car positive to the right. This is basically what we have decided so far. So what we need to do, we have this equation which we wrote over here, and when t was 0, s is equal to 0. So one, this condition is given, and other one is when t is equal to 3 seconds, what we need to do, we need to find out the position and acceleration. So this is basically again the given data that we have. So in paper, what you can do, you can have given data, you can have required data, then diagram, solution, assumption, everything you have to mention in your paper, in your solution. Okay, so these are basically three kinematic equation, and what we need to do, basically we need to find out position. So for position, we have this equation. Okay, so if I put equation for v, means this value for v here, and over here t, so this is same as t, and from here we can get this s. So let's use this one. Okay. So as I have told you that velocity or change displacement in this direction, it will be positive. On the right, it will be positive if it is moving toward the right. So v is equal to ds by dt. Instead of v, I have put this t3 square plus 2t. Let dt be moved to this side. Okay, when you move it to this side, what you will get on this side, it will be only ds. Okay, so ds, put integral 0 to s, 0 to t. So when you solve it, s upper limit, lower limit, upper limit is s, lower is 0, so this will become s. Then this t cube plus t square, so this is basically t, this one is 0. So what you will get, t cube plus t square. Okay, so what we need to find out, we need to find out the position at 3 is equal to 3 second. Okay, so instead of this t, you need to put 3 seconds. So put 3 seconds over here and 3 seconds over here. So this one will become 27, this one will become 9 when you add. So the answer will be 36 feet. So this is like the first answer. Then what you basically need to do, you need to find out the acceleration. Okay, so acceleration, from this equation we can find out. This is our required acceleration. Okay, and this one is dv. Yes.
सर सर इन पोजीशन हम ये कोऑर्डिनेट सिस्टम क्यों नहीं देख रहे, लाइक आई एक्स वाई जी, लाइक आई जे एंड के, लाइक पोजीशन है, डिस्टेंस तो नहीं पूछा, मतलब कि डिस्टेंस कितना कवर किया है, तो वो पोजीशन का पूछा हुआ है, तो हम एग्जैक्ट लोकेशन नहीं बताएंगे आई
उन्होंने
जे के की।
उन्होंने बेसिकली आपसे, मैंने शुरू में भी कह दिया था कि फॉर कैलकुलेशन पर्पस वी अज्यूम लाइक हम मैग्नीट्यूड को सिर्फ कंसिडर कर रहे हैं, ठीक है। इफ दे आस्क कि आप एग्जैक्ट हमें बता दें, सो देन इन दैट केस वी नीड टू शो दैट एज इन टर्म्स ऑफ फैक्टर। सो व्हेन दे आस्क फॉर पोजीशन, सो देन आप वो कर सकते हैं, सिर्फ मैग्नीट्यूड भी आपने शो करना है। बट व्हेन दे आस्क फॉर द पोजीशन वेक्टर, so in that case you need to either show the direction or you need to show the vector, for example with I, J and K, whatever system you have in that case, ठीक है।
ओके सर।
ओके, सो बाज़ औक़ात ज़हन में कंफ्यूजन होती है, लाइक कि सिंस डिस्प्लेसमेंट एंड वेलोसिटी ये सारे आपके पास वेक्टर क्वांटिटीज है, बट ओवर हियर हम उसको डायरेक्टली ट्रीट कर रहे हैं। सो उसका मैंने शुरू में जो सिंप्लीफिकेशन थी वो मैंने वहां पे बता दी थी कि फॉर दिस पर्पस वी आर डीलिंग इट लाइक दिस। ओके, सो हियर पोजीशन, अगेन पोजीशन को एग्जैक्टली इन फॉर्म ऑफ वेक्टर शो करने के लिए यू नीड टू हैव दैट पोजीशन वेक्टर। Okay, now for acceleration, we have this equation. So in this equation, instead of v over here, if I put this value, and dt will be on this side. Okay, so let's see. A will be equal to basically d by dt, and for v, I have put this 3t square plus 2t. So what we will get, acceleration is equal to dv by dt. Now in this case dt is downward, so either what we can do in this case now, okay, so d by dt, this is basically differential, right? आवाज आ रही है आपको?
Yes, sir.
Okay, so we are given with velocity. So velocity, how you can find out acceleration from velocity? If you are given with velocity, you can take its differential and you can find out velocity. So this is like the basic concept, and this is the basic concept is given in this equation. So acceleration is equal to derivative of velocity. So take derivative of this one, which is this one. Okay, when you take, so this one will become 2 3 is a 6, this one will become, okay, so derivative of this one 6t, and 2 minus 1, it will be 1 only. So this one will become 60, and over here 2 is constant, so it will have no effect, whereas only t, its differential with respect to t, it will be 1. So 6t plus 2, this is the equation that we get for acceleration. So when you put this, t is equal to 3 second over here, so 6 3s are 18 plus 2, so this one will become 20 feet per second square. So what things were required? Determine its position and acceleration when t is equal to 3 seconds. Okay, so over here it's showing that the acceleration or change in velocity. So the change in velocity that was basically 20 feet per second square. Okay, and since it's positive, means we are having positive sign, so this means the velocity is basically increasing, and the displacement or the position at that instant, it was basically 36 feet, or the change in displacement, it was 36 feet towards the right, or the change in displacement from initial position, it was basically 36 feet. So both answer we got over here. Okay, now rectilinear motion with constant acceleration. sometimes we assume this case like if the acceleration is constant. So in which case we can assume constant acceleration. For example, if we imagine the case of free falling bodies. If we imagine the case of free falling bodies, for example, if you throw a ball upward, so when the ball move upward, it will I mean, it will experience a force from the downward direction due to its weight, and as a result of that force of attraction, there will be the change in velocity of that ball. Change in velocity means when you throw it upward, initially its velocity will be more, and then as it moves upward, there will be a constant change in velocity, and then change in velocity will be definitely uh, the reduction in velocity. So initially, if its velocity is, for example, 100, then it will be reduced. Then again, when it's moving, so every second there will be change in velocity. That change in velocity is basically due to the gravitational field, and that is in that case it is equal to minus 9.81 meter per second square. Similarly, if you are having a ball and if you throw it from upward, up out means from top floor without applying any force, and the only force that it's having, it is basically due to its weight. So earth will attract that ball toward its center or toward its surface with the force of gravitation, and the velocity of ball will increase at every second, and the increase in velocity again it will be 9.81 meter per second square. Mean the change in velocity, it will be 9.81 meter per second. So that is basically the case of constant acceleration. So usually in case of free falling bodies, we consider it as a constant acceleration case. Okay, whatever I have said, so it will be better if I explain it with some diagram. So in coming lectures, sorry, in coming slides, I will explain the same thing again with a proper diagram, so you will be able to understand it. Okay, so again, the three basic kinematic equations will be used, but remember, in this case, we are imagining a constant acceleration case. That is rectilinear motion with constant acceleration. Okay, so we are having this equation, we are having this equation, we are having this equation. And if you remember, we had equation of motions in our physics course. Equation of motion, याद है ना आपको? जी, did you people derive equation of motions?
Yes, sir.
Okay, what was those equation of motion? कितनी equations of motions थे हमारे पास?
Sir, 3 थी.
Okay, anyone who means एक equation के बारे में अगर कोई बताना चाहे, any of the equation if you remember.
Vf square, Vf is equal to Vi plus At.
Okay, this was one of the equation. So basically with constant acceleration case, we want to derive those equation. So now let's see. Okay, so constant acceleration means that we will be having acceleration is equal to a constant, this one. Okay, so when acceleration is constant, this means the change in velocity is constant, right? Means, for example, the change in velocity, if it is 2, so it will remain 2. Means 2 meter per second, the acceleration will be 2 meter per second square. It will remain 2 meter per second square. It will not be changed. So in that case, the velocity will remain v naught and the displacement will also remain s naught. Okay, so a is equal to dv by dt. This is like the basic equation, and from here we can write dv is equal to a dt. As to find out this acceleration, what we can do, we can basically take derivative of velocity, and if we if basically we move the dt on this side, so we can get this equation. But in this case, we are having a constant acceleration, so we can put this value over here as c dt. So take integral of this one. This one will become v. The limits will be v naught dv, and over here this is constant. This acceleration is constant, so we can take this out of the integral, and the only thing that we will get over here, that will be dt. So when you take the integral, this one will become v minus v naught, and on this side what we will get, ac into t, right? So this is basically v minus v naught is equal to ac plus t. This is negative sign. If we move to the right of the this equality sign. So what we will get? We will get V is equal to V naught plus ACT. So this is the same equation which you just discussed, or which you just told, which is Vf is equal to Vi plus At. So this is basically the same equation. So this V is basically the final velocity, this is the initial velocity, this is that constant acceleration case, and this is the time. Okay, so this is one of the equation. So V is equal to V naught plus At. We will use this equation in our problems. Now let's look at the other one. We need to find out one for, this one was for velocity. Now we need to find out one for the position also. Okay, so as we know that acceleration is constant, so the velocity will be V naught and the displacement will be S naught. Okay, so V is equal to ds by dt. What we need to find out? We need to find out something for ds. Okay, so ds is equal to V dt, and we have this equation V naught plus ACT, V naught plus ACT. Okay, so when you put integral for ds, it will be S naught, and for this one it will be from time interval t is equal to 0 to any time t. Okay, and this value. Now V naught, if we take integral of this one will become V naught t, and when you take integral of this is like constant, this is constant, so this one will become t square by 2. So when you put the when you take the integral and put the limits, so you get s minus s naught V naught t, and the other one is 0, so this term will be eliminated automatically, and 1 by 2 ACT square. So when you arrange this equation, so s will become s naught plus V naught t plus half AT square. So this is the same equation which we used to pronounce, which we used in our physics course, that was s is equal to VIT plus half AT square. So in this case, that s on the left side, that is basically the displacement, which is the change in position, s minus s naught. Okay, so in this case, instead of displacement, we have write the change in position, which is s minus s naught. S naught is on the right side, so s naught plus V naught t plus half AT square. This is the second equation. Now let's derive another equation, which is the third equation of motion. Again, we are having the constant acceleration case, so we can use this third equation. We use this one, we use this one, and by using this third equation, basic kinematic equation, we can derive another one, A ds v dv. So A can be constant. Okay, and for vdv, what we can do, basically we can put the limits. So put limits on this one, s naught v naught. Okay, so s naught, when you, this is constant, so when you take it out, the only integral that you will get, it is basically for a constant, and since we are taking integral with respect to ds, so what we will get s, and the limit will be s naught. So when you put the value, we will get s minus s naught, and over here when you try to find out integral of v with respect to dv, so this one will become v square by 2, and when you put the limits, so half v square minus v naught square. Okay, now when you arrange this thing, so what we will get, basically take this 2 on this side. Okay, so this one will become 2ac s minus s naught, and over here basically what we get, we will get v square minus v naught square. So when you move this v naught to this side, so again it will become positive. So by rearranging the equation, what we will get, v square is equal to v naught square plus 2a s minus s naught. So this can be like the third equation of motion that we used to have, which was basically vf square minus vi square is equal to 2as. So again, that 2as was delta s, that was basically displacement, and in this case we know that displacement is basically equal to change in position. So this is the same equation. So if you are having problem in memorizing this one, so you can relate this equation with the basic physical equation which you already memorized. So based on this, you can write this equation. And even if you cannot memorize, it's not that much difficult. You just need to Memorize these equation, and from these equation you can derive anything. You can derive this equation of motion. Okay, so remember that these equations were useful when we consider the acceleration as constant, and in first two cases we took the initial time as 0. Okay, so as I have told you, a typical example of constant acceleration motion, uh, when it can occur when a body falls freely towards the earth. So if we neglect the air resistance and the distance of fall, if we imagine it is short, it is not out of like earth gravitational field, then in that case, the downward acceleration of body when it is close to the earth, it is basically approximately 9.81 meter per second square, or 32.2 feet per second square, which is basically the gravitational acceleration. So the constant acceleration example can be like free falling bodies. Okay, so now whatever I was explaining, it can be again better explained with the help of this example. A ball was thrown straight up in the air from 1.2 meter above the ground. So initially imagine that the person who was throwing the ball, he was at a distance of 1.2 meter above the ground. So the initial position of person is 1.2 meter from the ground. After 3 seconds, the ball returned to the ground. After 3 seconds, the ball does not return to this position. It returned to the ground, means it returned to 0 elevation. Okay, so the initial level, it is basically this one. So at this instant, initially, let's say this is the time is t naught, displacement, the position is s naught, and the velocity is v naught, and the s naught is basically equal to 1.2 meter. Okay, so the person has thrown the ball upward, and then it reaches this ground. So the time taken by this whole process, it is basically how much? It is 3 seconds. So after 3 seconds, the ball returned to the ground. So when the ball, let's say if this is 1, then this position, let it be 2. So let's say this is the position 2. So now at this instant, T2 is basically 3 seconds. We have this value now. S2, how much is S2? S2 is 0. Okay. Okay. Now what we need to do, we need to determine the maximum height it reached. So what is the maximum height? This is basically, initially a person was standing over here and ball was also at this position. So the maximum height will be this one. We need to find out S1. We need to find out this S1. So how we can find it out? Let's see. Okay. So initially, when the person throw the ball upward, like you can see over here, when the person threw the ball upward, so it was having some velocity, and definitely the velocity was more, means initially the velocity was more, but at it moves upward, like you can see, when the person threw the ball, initially it was having greater velocity. It moves after some time, the velocity decreases. Further as it moves, the velocity decreases. Again, the velocity decreases, and at this point, the velocity becomes 0. Are you getting this point?
Yes, sir.
Yes, sir.
Okay. Now, in this case, there is change in velocity. The change in velocity between these 2 points, right? Then again, the change in velocity between these 2 points. The change in velocity between these 2 points. Change in velocity between these 2 points, right? Why there is change in velocity?
Because there is deceleration.
Why there is
Velocity is
deceleration?
changing.
Why deceleration?
Because of gravity.
Because of gravity. Very good. And the value of gravity is how much? Acceleration due to gravity is how much?
9.8.
Okay, so this change in velocity, it will be 9.81. This change in velocity will be 9.81. This change in velocity will be 9.81. This change in velocity will be 9.81. So up till this point, we are having deceleration. And now after this zero velocity, again the velocity will increase, right? And as it moved onward, the velocity will increase more, and then more, and then. So now again we are having change in velocity, right? How much will be the change in velocity in this case?
Same.
9.8.
How much?
9.8.
Positive 9.8, sir.
Exactly. So this is basically like free falling body case. Okay. So it should be realized that the ball is subjected to a deceleration from position 0 to position 1 of 9.81 meter per second square, and then from position 1 to position 2 it is accelerated at this the same rate. Further, even though the ball momentarily come to rest at position 1 when v1 was 0, the acceleration at 1 is still 9.81 meter per second square. Means that at that instant there was that change velocity, due to which the change was means from 9.81 velocity it becomes 0 velocity, let's say. So there was still that change, and then after that instant again the velocity increases. So when the acceleration at that instant it was 9.81 meter per second square, so that is the case of constant acceleration. So what we need to do, basically we need to find out the position. So t naught was 0. At t naught was 0, mean when t naught was 0, the position where the ball was, or where the person was standing, it was 1.2 meter, and at that instant we didn't know at which velocity he thrown the ball, that initial velocity. Okay. At t1, what was the time? We don't know that, again the time at which it reached the maximum height. Then at that instant the height which the ball attained, or the maximum height, we need to find out that one. But we know that at that maximum height, what was the velocity? The velocity was basically 0, because when ball reaches till this position, that position, at that position the velocity becomes 0, and then the velocity start increasing. Okay. But we know that the acceleration is basically 9.81 meter per second square. Okay. When the ball reaches the ground, at that instant the time was basically 3 seconds, and the elevation was basically 0. And at that instant the velocity, mean the final velocity with which the ball hit the ground, again it is unknown. Okay. So what is required in the question? That is basically S1. Okay. So are you people getting that how I am finding these boundary conditions? कैसे मैं ये data निकाल रहा हूँ? समझ आ रही है सबको?
Yes, sir.
Okay. So now we are having, for constant acceleration, we just derive few equations, and these equations are basically given over here. That is S is equal to S naught plus V naught T plus half AT square. V is equal to V naught plus ET, and then again V square is equal to V naught plus 2 AC S minus S naught. Remember, I can apply this equation between state 0 and state 2. I can apply this equation between state 1 and state 2. I can apply this equation between state 0 and state 2. It depends. So, but if you apply equation from 1 to 2, so the values in this whole, it will be between 1 and 2, not 1 and 0, or not mix up. Okay. Okay. So again, like we are having these values. So for example, what I need to find out, basically I need to find out the distance S1. So you need to look at that whether I can find out this distance directly or not. So I have this T naught, which is 0. I have S naught, and I don't have V naught. Okay, so can I find out this V naught? So I need to look at this equation. What is the value of S, the maximum height? I don't know, but I know this S naught, which was basically 1.2. And if I, which S is known? This 1.2 and this one. So if I put this equation between 0 and 2, these two are known, right? This one.
Your cursor is not visible, sir.
Okay, now this one, right? Okay, like you see, in this equation, I have this S, I have this s, right? Two terms are known. Okay.
Yes, sir.
Okay, so if this is, so what I can do means this one and this one, I can apply this equation between uh naught and 2, from 0 to 2. Can I apply this equation? So from this equation, what I will get? From this equation, basically, okay, t is also given, right? So in this equation, we have this t, and we will be having this t. So what I will get? I will basically get v naught. From this equation, I can get v naught, right?
Yes, sir.
Okay, so let's do it this way. So let it be 2, this one not, and acceleration is constant, and final time is basically 3 seconds. So let it be 2. This one, this one also 2, this one also 2. So when I use this equation, as I have told you, okay, put this as 2 is equal to 0. Okay, s naught is equal to how much? 1.2.
1.2.
Okay, v naught is not given. V naught, let's see, it is given or not. It is not given. Okay, T2 is 3. So put it over here. Acceleration is constant. Free falling body is 9.81 due to gravity, and this is T. So from here we have find it out V naught. Now we have V naught, and now, okay, what we need to find out now? Okay, what we need to find? We basically need to find out this S,
V or S.
right? This is like the final answer. We are doing everything for this one. So if I use this equation, I can find it out. Even if I use this equation, still I can find out, right? How? Let's see. Uh, do we have V1? We have
Yes,
V1, right?
Yes, sir.
Do we have V naught?
Yes, sir.
Do we have A?
Yes, sir.
And what about S naught? Do we have S naught?
Yes, sir.
If this is
1.2.
if this is V1, this is V1. So this one will become S1, right?
Yes, sir.
Okay, so we can find out this S1 from here. Okay, let's say if this one become S1, if this one become S1, we already have S naught, right? है ना हमारे पास S naught?
Yes, sir. जी है.
Yes, sir.
Okay, we also have V naught. V naught है हमारे पास.
जी.
Okay, do we have T? T1 हमारे पास है?
नहीं सर, T1 नहीं है.
T1 नहीं है. इस इक्वेशन को बस इसी को यूज करें फिर. ठीक है?
जी.
Okay, so let's do it this way. So this one will become V1 square and V naught square 2AC S1 minus S naught. When you put value and you solve it, so you can get this thing. Okay, now I get S1 also. So from here I can find out T1 from this equation if needed. It is basically not needed in this question, but now I can find out T1. So in exam, if for example, if they ask you to find out T1, you can also do it from this one then. Is that clear?
Yes, sir.
Okay, so this is like the answer. Okay, now let's look at another example. Again, this is from R.C. Hibbeler book. During a test, a rocket traveled upward at 75 meters per second. Rocket is traveling upward at how much speed, how much velocity?
75 meters per second.
75 meters. So this means this is the initial velocity, right? Means from the very first statement, from the very first word, it's very difficult like to imagine something. But from initial statement, let's say it be the initial velocity. पूरा स्टेटमेंट पढ़ने के बाद हो सकता है अगर हमारी इमेजिनेशन गलत हो तो हम इसको चेंज कर सकते हैं. Okay, so during a test rocket travel upward at 75 meter per second, and when it is 40 meter from ground, when it is 40 meter from ground, its engine fails, right? इसका मतलब क्या है? इसका मतलब ये है कि हमारे पास एक रॉकेट है, वो जमीन से ऊपर की तरफ जा रहा है. स्पीड क्या है उसकी?
75 मीटर पर सेकेंड.
75 मीटर पर सेकेंड. ओके, सडनली उसका इंजन फेल हो जाता है. तो जब इंजन फेल हो जाता है वो डायरेक्टली वहीं से नीचे गिरेगा, यानी ये थोड़ा सा ऊपर जाएगा.
थोड़ा सा ऊपर जाएगा सर, इनर्शिया की
थोड़ा
वजह
सा
से।
ऊपर
ठीक है,
जाएगा.
ठीक है, एग्जैक्टली वो मोमेंटम की वजह से वो ऊपर आपके पास वो कंटिन्यू करेगा थोड़ा सा. ठीक है. सो नाउ व्हेन इट इज 40 मीटर फ्रॉम द ग्राउंड इट्स इंजन फेल. आपने क्या करना है? डिटरमिन द मैक्सिमम हाइट एसपी. व्हाट यू नीड टू फाइंड आउट? यू नीड टू फाइंड आउट द मैक्सिमम हाइट विच इट अटेन एंड इट स्पीड जस्ट बिफोर इट हिट्स द ग्राउंड. और वो स्पीड जब वो ग्राउंड को हिट करें. ओके, सो लेट्स से इनिशियली इनिशियल कंडीशन when during a test when it is 40 meter, आपके पास क्या स्पीड थी? At this level when we were having how much height? 40 meter. At that instant हमारे पास velocity कितनी थी?
75 मीटर पर सेकेंड.
75 meter per second. It was moving with the constant velocity 75 meter per second, right?
यस सर।
Okay, at point A engine fails. This means 75 meter per second velocity तो नहीं रहेगी, velocity ने कम होना है.
जी
ठीक है, और ये कम जो होगी किस वजह से? फोर्स ऑफ ग्रेविटेशन की वजह से.
ग्रेविटी की वजह से।
ओके, सो फ्रॉम नाउ ऑनवर्ड यहाँ पे जो डिसेलरेशन होगी, चेंज इन वेलोसिटी होगी, दैट विल बी हाउ मच? 9.81.
9.81।
ओके, सो दिस एक्सेलरेशन विल रिमेन कांस्टेंट हियर, एंड ये हाइट आपने बेसिकली फाइंड आउट करनी है, ये वाली. एंड देन फ्रॉम हियर व्हेन इट मूव्स बैक, सो अगेन कौन सी एक्सेलरेशन होगी?
ग्रेविटी की
9.
एक्सेलरेशन
9
9
पॉइंट. ठीक है, तो यहाँ पे फाइनली जब इस पोजीशन पे ये पहुंचेगा, सो यहाँ पे इसकी वेलोसिटी क्या होगी वो आपने फाइंड आउट करनी है. ठीक है. So it should be realized that the rocket is subjected to deceleration from A to B, from this A to B of 9.81, and then from B to C again, from B to C. So it is having how much acceleration and change in velocity? That is 9.81. Furthermore, even though the rocket momentarily come to rest at B, सेम केस जो कि अभी थोड़ी देर पहले मैंने एक्सप्लेन किया कि इवन अगर इस पोजीशन पे रेस्ट पे भी आ गया, स्टिल भी आपके पास यहाँ पे वेलोसिटी तो जीरो हो जाएगी, लेकिन स्टिल एक्सेलरेशन जो इस पॉइंट पे है वो 9.81 ही होगी. एक्सेलरेशन एट बी इज स्टिल 9.81 मीटर पर सेकंड स्क्वायर. ओके, सो लेट्स से वेलोसिटी एट ए, पॉइंट बी पे वेलोसिटी क्या हो जाएगी? जीरो
जीरो।
हो जाएगी ना. वेलोसिटी एट बी एंड देन एक्सेलरेशन, ठीक है, वो आपके पास 9.81 है. ओके, व्हाट वी नीड टू फाइंड आउट? वी नीड टू फाइंड आउट वीसी एंड वी नीड टू फाइंड आउट एसबी. ठीक है, यही चीजें हमने करनी है ना. डू वी हैव एस ए? एस ए हमारे पास है.
जी सर है।
अच्छा, और हमारे पास इनिशियल वेलोसिटी भी है, राइट?
जी
ओके, सो हमारे पास इनिशियल वेलोसिटी भी है, हमारे पास अगर इनिशियल वेलोसिटी हमारे पास है, और हमारे पास इमेजिन करें पॉइंट ए और बी के दरमियान, पहले देखते हैं पॉइंट ए और बी के दरमियान ये दो चीजें हमारे पास है, वेलोसिटी दोनों पॉइंट्स पे है. फाइनल वेलोसिटी, इनिशियल वेलोसिटी, वी आल्सो हैव एक्सेलरेशन. व्हाट वी नीड टू फाइंड आउट? वी जस्ट नीड टू फाइंड आउट एस बी, और हमारे पास इनिशियल एस ए भी है, राइट?
जी सर।
ओके, सो हमने क्या फाइंड आउट करना है? हमने सिर्फ एस बी फाइंड आउट करना है. we have initial final velocity, we have acceleration, we have initial position, we need final position. ओके, ये है हमारे पास ना.
जी
अच्छा, ये अगर हमारे इसमें टी का मसला आ जाएगा ना, टी T can cause
सर
issue.
थर्ड इक्वेशन अगर यूज करें
थर्ड,
तो
ओके,
आसानी होगी।
let ठीक है, चले थर्ड पे देखते हैं। डू वी हैव दिस वन? VB हो जाएगा ना ये?
यस सर।
डू वी हैव दिस वन? VA हो जाएगा ये।
जी।
ओके, डू वी हैव A?
यस सर, एक्सेलरेशन ड्यू टू ग्रेविटी।
और डू वी हैव SB?
सर एक एस है, एक नहीं है।
ठीक है, SA। So there is one unknown. What is the unknown? Is SB, right? And this is asked in the question. यही तो क्वेश्चन में पूछा गया कि आप फाइंड आउट करें। Determine the maximum height SB, right?
यस सर।
Okay, this one. Okay, the maximum height SB. So from here we can find out. I think it's simple maths now, right?
यस सर।
Okay, put these values and you can find out SB. Is it clear?
जी
Is
सर।
it clear? Okay, now let's see what else they want. Okay, now they want basically what else they are asking? Find out VC, right? So now see, now we have this VB and we have we want to find out VC, right? Okay, now we have SB. Do we have SB?
यस सर, वी हैव एस बी।
And what about SC? Do we have SC?
यस सर, वी आल्सो हैव एस सी by adding
Okay,
SA and SB.
okay. So what we need to find out? We need to find out only one velocity. So which equation should we use? Again, same. Can we use this equation between B and C? We have BB, right? We need to find out
Yes sir.
VC, right? We have SC, we have SB,
Yes, yes, sir.
right? We
Yes sir.
also have acceleration.
Yes sir.
So from this equation, can we find out VC?
Definitely.
Okay, so let's see. Okay, here. Okay. So when you put all those values, what you will get, VC is equal to minus 80.1, 80.1. So here you can find out this one. Is it clear?
Yes sir.
Okay. So this is basically your answer. So you can find out the velocity by using this equation. Okay. Is there any question in this problem? Okay, silence. So
No.
this means no problem. Okay. So let's see what we assume over here. Why is acceleration due to gravity negative? What you think? Why it is negative? Because acceleration due to gravity means the pull is towards the earth, right? So when an object when it moves up, what we usually do, we usually assume the velocity and everything in upward direction is positive, but acceleration due to gravity, it is downward, so that's why it is negative, right? So if up is positive and gravity points down, then acceleration due to gravity would be downward, so it will have negative magnitude, whether the upward direction will be taken as positive and downward direction as negative, or vice versa. So it simply depends on you. If you take the convention as downward as positive, so then acceleration due to gravity will be positive, right?
Yes
So
sir.
for example, when you to how we can say, like let me give you another example. For example, when you throw ball upward, so initially its velocity is 10. So as it's moved upward, there is some pull. So due to that pull, the velocity changes. Again, the velocity changes. Again, as it moves upward, with every second, the velocity changes. So you see, the change in velocity between these 2 points is how much? Between these two, 10 minus 8, 2, right? What about this one? 8 minus 6, 2. What about this one? 6 minus 4,
2 again.
2 again. So again 2. Again, here now the velocity is 0. But how much is the acceleration? How much is change in velocity?
It will also be 0.
Oh, no, it will not be 0. The velocity will be 0, but the change in acceleration is 2. The change in velocity is 2. Like, for example, 2 change here, 2 change here. So change in velocity is acceleration. So acceleration is 2 here, 2 here, 2 here, 2 here,
Yes,
2
sir.
here.
The change in
So now
yes,
when it's
the
0,
change
yes. So for the next second, again the velocity will be 2,
2.
right? For the next second, it will be 4. So this is like the case of constant acceleration. So you can means take it this way. Okay. So important points from previous lecture as well as from today. So Hibbeler book, what they do, they basically conclude at the end of every topic. They make some conclusive remarks. So dynamics is concerned with bodies that have accelerated motion, right? We define it like in last class. I defined that sometimes we define it as the mechanics of accelerated bodies, if you remember. Then kinematics is the study of geometry of motion. Geometry means displacement, velocity, acceleration, etc. Kinetics is the study of the forces that causes the motion. Then rectilinear kinematics refers to straight line motion. Speed refers to the magnitude of velocity. Average speed is the total distance traveled divided by the total time. This is different from the average velocity, which is displacement divided by the time. And a particle that is slowing down, this means the acceleration will be negative. It is also known as deceleration or decelerating. The body is decelerating. A particle can have acceleration and yet have zero velocity, right? We saw this case so many times in our lecture today. The relationship AdS is equal to VD. How it is derived? It is derived from these two equations. A is equal to dV by dt. And this equation is derived from this one and this one by eliminating, by taking dt out from this one. Is it clear?
Yes, sir.
Okay. Now what you can do, you can basically you need to do the sample problem 2-2 from your JL Mariam book, and you also need to do those problems. Okay, how you can do these problems? Let me show you. Dynamics book. Can you see the book?
Yeah.
Okay, so let me show you. For example, over here I have shown this problem 2-2, that I have asked that do this problem 2-2. Okay, so let's see what is this 2-2. Uh, the position of particle is given by s is equal to 2t cube minus 4t square plus 20t minus 50, right? Where s is in meter and t is in second. Plot the position. So how you can plot? Means on one side you can you will use Excel for this purpose. On one side you will be having t, and on other side you will be having s. You will make one column for t and one for s. On s, what you need to do, you need to write this equation. Okay, write this equation and then you need to insert plot. So when you insert plot, you will get a certain plot, but you don't need to copy it directly from your solution manual, right? कर लेंगे ये लोग. जी
यस सर।
Yes, sir.
ओके। तो जस्ट सिंपली एक्सेल में आपने क्या करना है, ये इक्वेशन पुट करनी है और उससे ग्राफ बनाना है। प्लॉट द पोजीशन वेलोसिटी, हाउ वी कैन डू वेलोसिटी, टेक इट्स डेरिवेटिव, जो इक्वेशन आएगी उसको आप प्लॉट करें, राइट। व्हाट अबाउट एक्सेलरेशन, टेक सेकंड डेरिवेटिव, तो वहां से जो इक्वेशन आएगी उसको आप प्लॉट करें। और यहाँ पे बता भी दिया गया है फॉर द फर्स्ट 12 सेकेंड ऑफ मोशन, तो आपने फर्स्ट 12 मीन जीरो से आपने स्टार्ट करना है, 0, 0.5, 1 या स्मॉल स्टेप्स ले लें, उसमें कोई वैसे भी टाइम नहीं लगता। अब उसको ड्रैग करें तो खुद ही 0.2 स्टेप से कर सकते हैं, 0.5 से कर सकते हैं, 1 सेकंड के स्टेप से आप कर सकते हैं, ठीक है। एंड व्हाट यू नीड टू डू, डिटरमिन द टाइम एट विच वेलोसिटी इज जीरो। So determine the time at which velocity is zero. So in velocity equation, you will put v is equal to 0, and then from there you can find out the time, right? समझ आ रही सबको? Now let's see
Yes,
problem
sir.
2.2/3. अगर ये देख लें, what is this? The velocity of particle which moves along the s-axis is given by this one, where t is in second, v is in meter per second. Evaluate the position s, velocity v, acceleration a when t is equal to 3 seconds. The particle is at position at s naught is equal to 3 meter and t when t is equal to 0. So ये चीजें इसी तरह के प्रॉब्लम अभी हमने उसमें किए हैं अपनी क्लास में, ठीक है। सो होपफुली यू वुड बी इन अ पोजीशन टू डू इट, कर लेंगे ना ये?
Yes, sir.
ओके, लेट्स सी 2.9 में देख लेते हैं। Experimental data for the motion of particle along straight line yields measurement value of the velocity v for various position coordinates. A smooth curve is drawn through the point as shown in the graph. Determine the acceleration of the particle when s is equal to 20 feet. When s is equal to 20 feet, right? ये आपने करना है। So क्या फाइंड आउट करना है? एक्सेलरेशन, एक्सेलरेशन की वैल्यू किस चीज के बराबर, dv by dt है ना जी?
यस सर।
dv by dt है हमारे पास एक्सेलरेशन। ओके, सो यहाँ पे dv by ds हमारे पास आ रहा है। सो dv by ds का कुछ कर सकते हैं, एक्सेलरेशन को उसमें मूव कर सकते हैं। लेट्स सी, थोड़ा सा
सर
देख
हम
लें।
इसे मल्टीप्लाई कर सकते हैं ds बाय
जी
dt से।
जी 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 बिल्कुल, एक्सेलरेशन इज इक्वल टू dv by dt है ना।
यस सर।
dt, तो ds से मल्टीप्लाई कर दें और ds से डिवाइड भी कर दें, ये ds हो जाएगा, ठीक है। और ये भी ds हो जाएगा आपके पास, राइट। समझ आ रही है?
यस सर।
ओके, सो dv by ds आप यहां से निकाल सकते हो। कैसे निकालोगे इस इक्वेशन से? ये इसको मैं डिस्कार्ड कर देता हूँ, जस्ट जस्ट आपको एक कंसेप्ट देने के लिए। अच्छा, ये देखिए, ये dv by ds जो है ना, इस कर्व का स्लोप होगा। तो इस कर्व का स्लोप कैसे कैसे निकाल सकते हो? तो ये आपके पास 2 है, ठीक है, 2 स्टेप्स के लिए, और यहाँ पे 2 स्टेप्स के लिए क्या है आपके पास, 15 है आपके पास। सो स्लोप आपके पास कितना हो जाएगा, y बाई एक्स कितना होता है आपके पास? फॉर एग्जाम्पल यहाँ पे 4 है, ठीक है, तो यहाँ पे
2
आपके
by
पास 20
15
है,
हो गए.
ठीक है। आपके पास हो जाएगा ये नहीं
2 by 5 हो जाएगा.
नहीं नहीं नहीं, एक मिनट, ये देखिए, यहाँ से 2 स्टेप्स आपके पास 2 के बराबर है, और यहाँ से आपके पास एक स्टेप जो बराबर है, ये आपके पास, ये 2 स्टेप्स आपके पास 5 के बराबर है। ये 2 स्टेप्स किसके बराबर है, 2 के, और यहाँ पे 2 स्टेप्स आपके पास 5 के बराबर है। तो ये 2/5 आपके पास हो जाएगा, राइट।
Yes, sir.
ओके, तो स्लोप आप ऐसे पुट कर लें, और रिमेनिंग आपके पास क्या गया था वहां पे दूसरे साइड पे, तो dv बाई एस, तो ये आ जाएगा ds बाई
dt।
dt, ds बाई dt। वो रिमेनिंग आप कहाँ से कर सकते हैं, क्या क्वेश्चन को देख लें जरा दोबारा। Experimental data for the motion of particle along straight line yield value for the velocity v of various position of coordinate, ठीक है। सो ds by dt आपके पास क्या चीज है, वेलोसिटी है ना।
Yes, sir.
अच्छा, सो s इज इक्वल टू 20, ये आपके पास s इज इक्वल टू 20 है, यहां से आप आएंगे, ये आपके पास s इज इक्वल टू 20 हो गया। ठीक है, s इज इक्वल टू 20 पे आपने क्या करना है, यहां से ये वैल्यू ले लेनी। ये कितनी वैल्यू है आपके पास?
ये 3।
3। तो आपके पास ds बाई dt कितना आ जाएगा? आपके पास 3 आ जाएगा। दोनों को जब आप मल्टीप्लाई करेंगे तो आपके पास एक्सेलरेशन की वैल्यू आ जाएगी। तो यहां से आप 3 ले लेंगे, और जो स्लोप आपके पास था वो स्लोप कितना था? वो आपके पास 2/5 आ गया, राइट। सो 2/5 मल्टीप्लाई बाई 3 आप करेंगे तो आपके पास एक्सेलरेशन की वैल्यू आ जाएगी। समझ आई या नहीं? ऊपर ऊपर से गुजर गया?
आगे सर।
ठीक है, तो इसी तरीके से आप ये सारी प्रॉब्लम्स वगैरह कर लेंगे। ठीक है, सैंपल प्रॉब्लम 2/2 वो तो ऑलरेडी सॉल्व है। इस तरह 15, 18, 35, सो होपफुली आप इसको कर लेंगे। सो सेम प्रॉब्लम, सेम जो स्लाइड जिससे मैंने आपको पढ़ाया है ये सेम गिवन है गूगल क्लासरूम पे। इफ यू आर हैविंग एनी क्वेश्चन रिगार्डिंग टुडेज क्लास यू कैन आस्क, अगर नहीं है तो फिर रिकॉर्डिंग को मैं ऑफ कर देता हूँ। जी,
No, sir.
रिकॉर्डिंग ऑफ कर दूं?
Yes, sir.
ओके।